So this is next. Okay, thank you. Assalamu alaikum. Good morning, ladies and gentlemen. First of all, I would like to thank the organizers, to thank the country of Saudi Arabia for inviting me and inviting to be the first speaker, the first official speaker of this important conference. It's a big honor for me, and it is something really I'm proud of. It's exactly 50 years ago when I was first in contact with palms. I was asked to give some help to the Philippines in 1973 to work on coconut palms. And this was the beginning of a long, long journey through the world of palms. And I remember a very early phrase of the Food and Agricultural Organization. They said, they named palms as the tree of life. It is a tree, it has the shape of a tree, but more important, it is the tree of life. It serves people, but is also a part of culture. It's a part of history of mankind. Maybe even more than in many countries, at least in many countries, even more than forests. And I'm very happy to be here and to share some thoughts about palms and utilization of palms. And for this keynote address, I'm only one part. The second part will be taken by my colleague and friend, Professor Medani from Egypt. He will concentrate on the fiber bunch of the palms. I will concentrate more on the palm trunks. So if we look on the palms worldwide, most palms grow in tropical and subtropical regions. We have more than 2,500 species worldwide. About 100 are important of commercial value, and about between 5 and 10 palm species make up 95% of all the biomass available in the palm group. And among that, the date palm, the oil, the coconut, the sugar and sago, and some more are the most commercial species. The main target of growing palms are the fruits. But as we see, as we have already seen during the last two Biofiber conferences, and we'll see even more to these days, the fibers, the byproducts, may be of high importance for the future. So palm byproducts is something for the future, even more than it is today. The fiber production is generally high compared to the fruit production. And so the question arises, why are we not using more of the fibers, more of the byproducts? So if we look on these three main palms, the oil palm is by far the biggest in plantation size, 35 million hectares today worldwide. Of the oil palm, the coconut palm is about 10 million hectares, the date palm 2. But the area is not a clear indicator for the importance. Even if you have a couple of hundred palms at one specific point, this might be very, very important, as you all know here in these Arabic countries. If you look on the right two columns, you see the million cubic meter of trunks per year available, and the last column gives you an impression of the fronds and leaves volume, the mass, which is produced every year. So if you go to the line total, it is 300 million cubic meters of trunk volume every year, which is grown. I'm not saying we shouldn't use all this. I come back to this later. And it's 400 million tons of leaves and fronds fiber material. This is impressive. These are really impressive figures. If we compare this with the wood production, these are figures from the FAO, Food and Agriculture Organization, for 3 years, 2000, 2015. Industrial wood, wood fuel, and the right column is the total wood production and consumption. Production is higher, this is the consumption. You see 2015, it's 3.8 billion cubic meters. It's also impressive. It's half a cubic meter of each inhabitant of the world. It's quite a lot. But if you look to the palm mass available, you see this in blue. In 2015, if we would count only 50% of the trunks and 25% of the other fibers of the palms to be used. This is a theoretical value. This could give 7.5% compared to all the wood which is used worldwide. And if we consider that palms are not growing worldwide, but growing in very specific areas, you can imagine that the importance of palm fiber could be tremendous. Could be tremendous if we do wise and correctly. And even in 2050, there's a projection, the importance could be higher and could be 11% compared to all the wood will be available worldwide. And remember, this is only 50% of the trunk biomass and 25% of the fiber biomass. It depends how much we use. It could be more, could be less, depending on the situation. So I first would like to talk about the palm trunks, because that's my field for 50 years. Dr. Mitani afterwards will talk more about the leaves, the fibers from leaves and fronds. So we consider this as a renewable biomaterial, which is important nowadays. So it's a door opener for the society and the politicians. If you have a renewable and bio, these are very important expressions. It's an agricultural residue. It has very good material properties and is comparable even to many timber species. So there is a possibility for substitution of timber. And we have some problems with biomass. I will come to this back later. And the use of palm biomass could create jobs, supports especially the rural development, and generates income, supplies products and energy on a sustainable basis. That's very important. And it can substitute, for example, tropical timber, where tropical timber are endangered. So if you look on the trunks are quite impressive. They have different sizes, the three main species, cocoa, oil, and date palm. Coconut palms are the highest palms, but the volume, if you look on the bottom, the volume of a trunk is almost the same of each of the species. The trunks are quite straight, have a uniform size, so they are ideal raw material for industrial processes. If you look to normal timber species, you have so many different species, so different trunk shapes, thin ones, thick ones, crooked ones, knots. We have no knots in palms. So it's a very uniform material. And it has some very special features. Palms are monocots, monocotyledons. they grow differently compared to normal trees. A normal tree grows around the trunk with the cambium. The palm has its cambium on the top of the palm. It grows only on the top, therefore you have different ages of the tissue. On the lower end of the trunk, it's old and it's strong, high density. On the top, it is more light density and it's less strength. The same is across the trunk diameter or along the trunk diameter. In the inner part is softer, the outer part is much harder. So this is a challenge, but it's also for processing, but it's also opportunity. You select from a palm trunk the material for different uses. So it's a multiple use material, not very uniform. This is a challenge, but it's also an opportunity. So you see here, in blue, you see the coconut. The right-hand column is the peripheral zone, high density. You see in green the oil palm, which is much younger than the coconut, therefore the density is lower. Coconut grows until 80, 100 years, the oil palm about 25 to 30 years. And in blue, you see in green, no, in red, you see the date palm. And the date palm, astonishingly, compared to the other palms, has a density distribution which is very equally over the trunk diameter. And the same is with the strength properties. Again, the highest density coconut has the highest strength. The oil palm in green has the lowest strength because that's the lowest density. And the date palm in red has quite a similar strength properties along the diameter of the trunk. So the date palm trunk are somewhat ideal for processing because it makes it much easier. So this is just a table, gives some information about the properties and the variation of the properties. This is important. If you look to for example, oil palm, the density, first line, between 220 and 550 kilograms per cubic meter. This is the challenge I spoke about. And the modulus of elasticity, the other strength properties. The coconut has even higher density, higher impressive strength properties, really impressive strength properties. If you compare, for example, the modulus of elasticity of coconut goes up to 114 compared to Norway's spruce, which is the common tree species worldwide. It's only about 100. And you see also the date palm has medium densities and medium properties, but very uniform. So we have a wide possibility to use trunk material in different applications. So it's a challenge. It's a challenge for research and it's a challenge for industry. But it's a huge opportunity to make the optimal product out of this material. But we have to do it wise, and research is absolutely necessary. That's why we are here. That's why we are exchanging our ideas, and we should bring our ideas to the real world. There are some problems associated with the use of palm fiber material, which is mainly ash content. You see the ash content, oil palm and date palm are quite high compared to coconut or even to pine wood. And what is even more important is the silica content. Silica is a very hard crystal. It's very difficult to process. It requires a lot of engineering and money for the cutting of the wood. And oil palm has, here it is at 0.65% of silica. We have seen oil palm trunk material with more than 3% silica as well. And you see date palm has much, much less, and coconut also. So this is, in literature, this is often a little bit overestimated, the silica problem. I just have a huge project on rice straw, utilization of rice straw. There we are talking about 15% of silica. This is a challenge. Not here with the palms. This can be solved. And we have solved this problem over the last 10 years. So processing is not a real challenge. That's for this slide. It's not a real challenge. We can manage this. So we have some pros and cons for the utilization of palm trunks and the palm fibers. It's a renewable resource. It has quite good material properties. The use of palm material can reduce some problems in the plantation when we recycle all. In the case of clearing the plantation, if we recycle all the biomass, we may have some problems with fungi and with beetle attack in the plantation and in with the new plants. And as I said already, the economic aspect is quite obvious. And I will show you some figures later. But of course, there are also some controversial arguments. It has never been done on an industrial scale. We know a lot of uses of palm fiber material, handicraft, or small-scale industry, but not a big-scale industry or a bigger-scale industry. This is a new challenge. Also, we have to respect the nutrient cycle in the plantations. We cannot take all, cannot take everything, because as I will tell you on Thursday, we have done some nutrient cycle studies, so we are limited in the use. It depends on the palm species and on the site specification, but we are limited, and we know the limits already. And the same is with the organic soil. And some people, this is an argument I heard very often during the last 20 years, if you improve palm byproducts utilization, this may lead to higher profitability of the palm business and will destroy forests. That's a very short argumentation, but very impressive argumentation. This is mainly related to oil palm, because of course oil palm plantations grow on tropical forest sites, because all the tropics, most of the tropics were covered with forests, not the dates, not so much the coconut. Coconut palms grow along the coastlines in the tropics. But the oil palm might be a problem. So most countries have stopped planting oil palm on primary forest land. They use only secondary forest land. So this is not a good argument on the long run. Profitability, you have to have profitability, otherwise the world will not turn around. So overall, this is a very complex palm fiber, palm products utilization is a very complex issue. It starts with the resource management. How much can we take? What part can we take? What is the recycling aspect of the biomass? And so on, the left-hand side. All these technical, environmental, and economic aspects. Even the collection. If you consider, let's say, using palm fronds for panel production, one palm frond has a weight of 2 or 3 kilograms maximum. And if you need 100,000 tons, that's a high number of palm fronds you need and have to harvest to transport. So this is also a technical but economical aspect. Then you have all on the left hand down, on the bottom line, all these policy matters, environmental issues and so on. You have to deal with many, many people if you say, well, let's use palm byproducts. And of course, you have all the processing aspects, as I told already about. And we have a challenge in products and product development. We cannot say just, okay, let's make the same piece of furniture of palm fiber material rather than of wood. This is different. It's a different world. It needs reinventing the wheel. It needs observation of all these 4 main aspects to have success and to be sustainable. Success is one side and sustainability is the other side. So a few good examples of, in this case, coconut, utilization of coconut wood, I call it coconut wood. You see flooring products, 3-layer flooring products with a high-density material on the surface, the lower density material on the middle. Or here, example of a conference center of the Grand Hyatt Hotel in Bali, totally built of coconut wood, totally built. They turned down the concrete buildings and set up new buildings totally from coconut wood. Perfect in design, and it will last at least several decades without any problem. Okay, coconut wood is because of the density, the strength properties, so the number 1 for the building purposes of the palms. So the main possibility we get through a combination of the different palm material. As I said before, we have the very heavy parts in the trunk, we have the very low weight trunks in a part with different properties. So the gluing together at the top, the window frames. We have produced window frames from palm wood 40 years ago. The windows are still in service in Europe, withstand all the weather, no problem at all. So the glued laminated timber is one of the possible products. We'll listen to contribution on Thursday. Or the cross-laminated timber. It is a big issue nowadays in the building sector, wooden building sector, or the flooring or other building components. The building components you can bring together the outer layers for strength properties, high-density palm material, and in the middle of the layer you bring in the low densities for insulation purposes. So we have 2 main aspects, strength and insulation in one product. Okay, a few words about the oil palm. An oil palm plantation, about 25 years old. You see the trunk of the oil palm, 50 centimeters in diameter, 10 meters long, perfect for any industrial processing. We have, with the oil palm, we have some more problems. The low density means we have very high moisture content, which is a challenge for drying, a really challenge for drying. And we have also a lot of sugar because the productivity of oil palm is very high, so needs a lot of sugar and starch inside the trunk as a store for sugar. And this sugar is loved by fungi later on. So we have to manage the sugar content in the oil palm trunk. But there are solutions for it. Also, the oil palm trunk is very ideal for processing. You see the density, high density is about 40%. The low density is about 40%, medium density 40%, and the high density is about 20%. So if we process the oil palm trunk in the optimal way, we get 3 main products for different uses. So this is just a figure from our pilot processing. So we did it during the last years. We did several hundreds of cubic meter pilot processing. And these are some products. We will have products on display outside later today and throughout the Congress, and you can touch the samples, the different products. So these are block boards, or on the right hand, a heavy-duty door panel, for example, for the hotel sector. Or you have laminated beams, glued laminated timber from different densities of palm trees. So coming more to the end of the presentation, so I have an example for a processing unit. And very similar unit has been built in Malaysia last year and will come into operation this year, or is already in operation, but will come to the market with the products early next year. So this is, if you're interested, you can look to IOI Pulpwood. They are using our technology we have developed over the last 15 years. And they have set up a sawmill with a capacity of 200,000 cubic meter of oil palm trunks. They use 60,000 hectares of their own plantations for sustainable supply. This is a 25 by 25 kilometer plot, so the transport distances are very short. So this gives a good cost-benefit ratio in the plantation. They will take out 50% of the trunks after plantation clearing, and they will produce 90,000 cubic meter of dry lumber, and from that about 65,000 cubic meter of furniture and building components to be sold within Malaysia, in the region, and maybe worldwide. So on the right-hand side is just a theoretical figure. This is not the original figure from their feasibility study. So this could give an overall turnover of $30 million US. This factory, this means a value of $150 US per cubic meter of trunks. This is quite good compared to forests, normal wood from the forests. And they could employ more than 1,000 staff in this business. And the product value will be about a bit more than $400 per cubic meter product. And this will be quite well-paid jobs with about $25,000 per job turnover. So this is something of really impressive development. That's the first plant worldwide at the moment. So we have more possibilities to use palm trunks, all palm trunks. So the most favorite, to my understanding, are the solid wood-based products, because they have some advantages. The main advantage, of course, for the business is they will achieve the highest revenue compared, for example, to panels. And the solid palm wood, you sell not only a volume of palm wood, a cubic meter, you sell the nature of wood. You sell the color, the texture. You remember the flooring material. This is a very beautiful design. You sell also this, and you sell a piece of nature, which is also important. For example, in the case of date palm products, you sell history, you sell culture together with the product, not just a piece of material. This is a value. These side values could be even more important, and people are willing to pay an extra price if they get something special. So this is why I personally favor, if you see the raw material, the palm raw material in the finished product, because then you have a big advantage over commercial timber species. You hardly see what it is. And the same is if you produce, for example, particle board or medium density fiber board. Nobody realizes what type of fiber, what the history of the material is. So my favorite are the plywood, and we'll hear also presentations on plywood from palm wood, and the solid wood. But of course, the other products mentioned here are also important because they are mass products. You can sell volume, and you can make good business as well. So I remember, or you can look to the internet, desertboard.com, Thala in where is it? Abu Dhabi. They set up the first panel mill based on fronds from date palms. With a capacity of 120,000 cubic meter of oriented structural board. They just went on stream last year, and they are started to sell the products. This is a very unique, the first of its kind factory in the world. Desert board, Thala board in Abu Dhabi. Okay, two or three slides more. The CO2 aspect is quite important for the utilization of renewable material, the same as with the palm. So if we calculate, and at the very last day of this conference, we'll listen to Dr. Reinhardt from Germany. We will talk about CO2 aspects and life cycle aspects on wood and palms in general. So if we do all the calculation wisely, so we see an effect of CO2 mitigation of roughly 1 to 1.5 tons of CO2 for each cubic meter of palm product, palm-based product. So this comes from the energy effect, from the material substitution effect. You remember the example from Bali, a coconut wood building rather than a concrete building, and also the storage of carbon in palm material. 50% of the palm fiber is carbon, which is stored over a long time. So make it easy, 1 ton of CO2 mitigation per cubic meter of palm wood product. And if we take this figure, then we can see what could be the effect of carbon mitigation in palm growing countries. As an example, Indonesia, if they would use, theoretical figure, 65 million cubic meter of palm trunk one day, maybe in 2050 or 2040. This is 50% of the availability they have. Then this would come out almost 10% of the existing carbon CO2 emission in Indonesia, sorry. So use of trunks, use of palm byproducts could be an important aspect for all the CO2 mitigation work. And we are looking to Dubai these days. What will be discussed in Dubai? What will be the conclusions in Dubai? We can do our job to contribute. And this is not a very small part. This could be, at least locally, regionally, could be very impressive. So if you look to palm fronds, this is just a startup for Dr. Mirani now. If you look to palm fronds, the volume is quite high of the leaves and fronds, 450 million tons per year. We need most of it for nutrient and biomass recycling, of course, but some 20 to 30%, we have done a lot of studies, could be used for material purposes as well. Not so much for energy. Use material first and then produce energy from the old stuff of products. With the date palms and coconut and oil palms, it's a bit different because, as you know, date palms grow in very dry countries, dry regions. So even the logistic to get rid of the palm fronds and the palm leaves is quite difficult. With the oil palm, they grow in wet tropics. It's different. They decompose very fast on the ground, and this can create some problems with fungi. And we can use the fiber material for energy purposes as well. For example, we can produce energy material, but the value is quite low compared to value of other products. We can produce pelletizing pellets mixed with fertilizer, for example. I will report on this on Thursday. This has a higher value. And we can use also the fronds and the leaves for making panels, as Talabot in Abu Dhabi is doing right now. This could give some profit or make some economic value, but we have much more possibilities because palm fiber is a very excellent, very, very excellent material. And I have a very excellent expert for this, Professor Medani. It's your turn now. Thank you very much for listening. And I'm happy if we can have discussions in the coffee breaks, during lunch break, or even in the evenings. Thank you.